Medico-chemical dissertation. First on the origin and progress of chemistry. Which, with God's favor, and under the presidency of Dr. Jacobus Lamort, Ordinary Professor of Chemistry and Medicine, in the illustrious University of Leiden, is proposed for public discussion by Joshua Lentz, of The Hague, on the 21st day of October, before noon, at the usual hour and place. Leiden. At Abraham Elsevier, Printer to the Academy. 1702. To the most celebrated and most learned man, Jacobus Lamort, Doctor of Medicine, most experienced practical professor of chemistry and medicine, and my fortunate teacher, worthy of reverence while my soul still breathes. Joshua Lentz. The Respondent. Medical Disputation on the Origin and Progress of Chemistry. Thesis 1. Nothing ought to lie nearer the heart, in rightly cultivated studies, than that all the things subjected to those studies be most carefully observed and compared with one another. In observation one must distinguish everything to be treated into its proper classes, species, and names, by which a knowledge of the matters to be handled, both superficial and more inward, can be obtained or acquired. By such comparison study and exercise are referred to other matters as well, and to mutual relations and extensions of experiences, so that what proceeds from the very bosom of this art and science may be distinguished from those things that have taken their rise from the fountains of other studies, and that these may serve this or that either of necessity or by chance as an aid. Thesis 2. The chemical study, distinct from other studies, such as mathematics, anatomy, botany, physics, and the rest, therefore recognizes certain limits, within which it brings forth, extends, and confines its inquiries and observations. This delimitation consists in observations of the motions of bodies that are heavier and coarser, rejoicing, as it were, in a certain action and passion, arising from the mutual approach and withdrawal of the little corpuscles that are to be handled in this art. The extension of that study proceeds from experience drawn from these actions and passions of bodies to the investigation of causes, and to the pursuit of the ends or effects that result from them. Thesis 3. The motions of the heavier bodies, which chemical study sets before itself, never exclude the activity and prime impulse of the most subtle bodies, although chemists speak of them but rarely, speaking almost solely of fire, as of a visible and sensible, most rapid terrestrial motion, while its hearth is elsewhere, acknowledging its subtler seat, for these matters do not, strictly speaking, belong to their study in this way, but pertain to a more general physics that regards the works and experiments of sensible, and therefore more fluid, things. Accordingly, chemists have brought under chemical study those things which they have turned rather to the use and benefit of humankind than to mere contemplation and adornment, so that from these same things they might at once establish a fruitful and light-bringing art, serving the whole human race as far as lies in them. Thesis 4. Recognizing its own loftier part, for these matters do not properly belong to their study in this manner, but look rather to a more general physics concerned with the works and experiments of sensible things, which are more fluid. Therefore those things which fall under chemical study are such as chemists have drawn more to the use and convenience of the human race than to mere contemplation and adornment, so that from these same things they might at once frame a fruitful and light-bringing art, serving the whole human race, as far as in them lies. The chief means by which this art was raised to a higher discipline were sensible observations and the many mechanical arts which flowed together into this one art, so that, through innumerable and toilsome investigations of heavier matters, they could at length arrive at certain hypotheses and systems necessary for completing this study, passing from autoptic asterisk observations to the more obscure and hidden things which, by the faithful or unfaithful outcome of affairs, became evident to them, both for establishing their science and for settling and extending their art. Asterisk autoptic equals seen with one's own eyes. Thesis 5. If one considers how very lowly the origin of chemistry is, it can move no contempt for it, since all things of the world were born in their cradles from subtle beginnings, and for the most part come forth into the light from an obscure state as it were from darkness, when carefully cultivated and furnished. The first origin we recognize is mere coction or evaporation of warm bodies, where the more fluid substances were separated from the thicker and more solid, as is evident first in drying, toasting, roasting, evaporation, and in most culinary exercises. In this operation the ancients could easily observe, for example from the fragrant odor, that certain fine little corpuscles ascended, torn away from the grosser parts, which by their penetrating breath affected the senses, now in a pleasing, now in an unpleasing way, lurking in the watery particles of meteoric moisture. Hence the ancient chemists prepared capon water, swallow water, and other waters from meats that were well digested and wholesome, supposing in them a strengthening or penetrating power, made manifest by the strong fragrance. Although these do not altogether or always answer the intention, yet they are fairly to be excused in this opinion, since even to this day errors of no small note persist concerning so-called cold waters and other preparations still in use in very many shops. In waters the pharmaceutical chemistry itself persists for a very long time, for the ancients believed, relying at least on some reason, that everything serving vegetative life is constituted and retained by means of water, as that by whose moderation the heats are restrained by the hardness of bodies, and their softenings are obtained by a kindly distribution and moderation. And they observe that the behavior of all fluids depends on this. An observation drawn from the air laid the foundation for the further advance of chemistry, namely the ascent of dew into the airy regions, raised by the heat of the sun, and in the evening settling down again, it presents itself like an aqueous distilling humor, gently washing and moistening the whole surface of the world, with an excellent and truly universal refreshment of bodies of every kind. To this phenomenon there may rightly be added the upliftings of clouds and mists, whose dripping rain and the notable changes of waters are marked by the same signs, as one may see in distillations, and these distillations seem later to have been devised with lighter instruments, and to have preceded those that afterwards came to light for human use as well as for luxury. Thesis 6. From cookings, while they themselves, as it were, with a vital spirit were turning things into solutions under the form of juices that melt away, there first emerged the rudiments of decoctions, extractions, and solutions. These have remained among the so-called Galenists, who still shrink from the abuse of spirits and salts, although under a changed name they appear to do and intend the same things, if one judges by the rule of rational experience. Whether one prefers to call these operations natural or artificial, they are handled and evaluated as follows, as the ensuing points seem to teach. 1. Waters are never given simple, but are always composite. 2. The differences among waters do not depend on the waters themselves, but on other mixed bodies swimming in them. 3. These little corpuscles are always saline, composed in a way very familiar to chemists. 4. These salts, imprisoned and fitted to earthy particles of various shapes and sizes, impart every change to waters and to salts. 5. Every action and passion, both in the corpuscles that approach and in those that withdraw, belongs to this composite body solely through the motion of fire in weaving together the texture of more solid things to be cooked, and therefore from these imprisoned particles one must expect every variety of action. Thesis 7. If anyone doubts these matters, let him go to the cooks themselves and the kitchens, there he will at once learn the difference between well water, rain water, and snow water, boiled and raw. Indeed, let him consult the infusions of tea herb and of countless other vegetables, let him observe the dyeing arts, and very many other mechanical operations, which in different regions vary with different degrees of heat, and in divers, in different kinds of weather, now familiar, now foreign, now impossible. Finally, let him set before himself, or at least bring to experiment, the very great difference between rainwater newly fallen and that long stored or retained. Let him pursue the nature of waters in a thunderstorm and outside it, in waters that settle down or that are gathered in wintertime, let him examine the varieties of dew, and, lastly, the diverse fluctuations of winds, as much in the tracts of clouds as in springs, and in the caverns of the earth and hidden subterranean crypts stirred by an inward or outward force. Here and everywhere wonderful secrets of nature will reveal themselves, secrets which, perhaps by being too much neglected while men's minds were held in suspense, have provoked quarrels and driven people into ill opinions, giving birth to and half-forming the Galenic and chymic sects. Thesis 8. Whatever has here been said about waters in their grosser state, the same we pronounce of air and winds, in part they are resolutions and exaltations taken from water, in part they are the offspring of a subtle matter joined to watery little corpuscles, spiritual, whence even the Hebrews did not scruple to call the air a heap of the thinnest waters. That wind is produced from waters no one will deny who, at least by experience, knows nature's play. It draws its origin from a certain expansion of vapor, light or heavy, and the very leapings, saltations, of natural breaths must be referred to waters, driven on by an igneous vigor and propelled through the narrower passages or pores of solid bodies. This is evident in the Yalapile, in most first boilings, at the beginning of motions that proceed from the fiery power of bodies, so that they move and shake even whole heavier instruments. They display the wind of aqueous exhalation. If bereft of that moisture they are consumed, whereas, supplied with it, they are seen plainly to burn with flame, and to act with smoke. These things are plain enough to the curious by experiments prepared with fire and water, in the circling of several instruments like little mills, in green wood, where fire committed with greater or lesser violence acts through moist air or through dry air, for often fire is 6 times, indeed 10 times, stronger in cold and moist air than in warm and dry. Accordingly, winds are greater and longer lasting around rainy seasons, especially in autumn and winter, and who does not see that every motion of whirlwinds and vortices is most excellently promoted by waters, driven at highest speed and fashioned into the form of wind, both in a thunderstorm and in the water-bearing hollows of the earth, without doubt compelled to this action by inward sulphureous fires and a violent internal motion? Indeed, if we observe most things, we shall see among the chemists the more excellent internal motions there is left us no room for doubt. Quicklime remains quiet so long as it is dry, and fires, so long as they smoke, are to be regarded as in part aqueous, and to be judged differently in their operation. This is attested by our turf, various kinds of wood, pit coal, and other materials imbued with inward moisture. But as soon as they are deprived of it, the difference appears, clearly seen in the charcoals of rightly dried woods, most of all in our turf and pit coal, which produce no alteration in metallic infusions, otherwise greatly disturbed, and especially in the nobler metals in cupellation and their purification. We notice the same, with different winds, around vegetable matters, and likewise different affections in bodies that are moist and dewy, carrying with them a great mass of matter. Yet this does not hinder our admitting the elasticity of air and the irradiation of light, or of a most subtle matter, as properties proper to air and ether, communicated by secondary instruments. Thesis 9. Chemistry advanced further from the noblest and best-known juice of grapes. For when this, by fermentation, was reduced to wine, it brought delight not only to those who taste it, but, moreover, from its generous exhalations the burning wine, brandy, produced from it furnished, as it were, the first beginnings for obtaining a more spirituous water. Led on by these properties to further inquiries, ever more harmless, their search extended to the juice of the sugar cane, to honey, and even to the fatty saps drawn from trees, proceeding by the same process and arriving at the same ends. Among many peoples living in warmer regions this is a familiar thing, where from the same materials they are wont now to prepare so-called artificial wines, now vinous spirits. From these fermentative motions they were afterwards able to pass to other internal actions, offering clear signs of change, with a separation of the subtle particles from the gross. These things are evident in dung, in the putrefaction of bodies, in hay laid up damp and in other bodies that grow warm of themselves, which reveal themselves by a notable stench or odor, through their particles now released from prison, saline and oily. In these two motions together they were able to collect and observe that these bodies yield, the burning spirit, alcohol, the acid spirit, vinegar, the alkaline spirit or volatile alkali, ammoniacal spirit, and oils, now pleasant-smelling, now ill-smelling. Thesis 10. The inconveniences of life drove men, in order to obtain conveniences, to make and inquire into many kinds of household implements. Thence arose an investigation of things underground, especially of metals, to be drawn forth for various, more solid instruments, and this inquiry gained more and more strength. At first, therefore, they took the purer and more refined metals as they exist in mines and pits, by the intervention of fire, since this was the most convenient way which nature herself seemed to supply. But afterwards, when it appeared that these were not sufficiently purified, although they were accustomed to discharge slags and certain dregs, they were compelled, little by little, to set themselves to driving off those dregs, so that, separated from them, the metals might shine with greater splendor. Hence came the art of metallurgy, and finally, as the ignoble desire of men prevailed, the alchemical art came to light, in which later generations strove to prepare a base metal into something nobler. From this inquiry, as they looked further into the depths of the earth with the harmless diligence of miners and diggers, there fell under consideration the various operations both of mineral waters and of the salts themselves that fall upon and act upon the earths, altering them in many ways, dissolving them, even transforming them, as is apparent in vitriols, alum, rock salt, niter, sal ammoniac, and the like. Afterwards they tried to imitate these effects by their own methods, where, with this mild watery saline fire, they strove to melt and dissolve metals, minerals, and earths, imitating nature by art. And when they easily observed that salts are not of one and the same kind and character in this place and that they do not act in one and the same way upon all bodies, they interpreted these differences, conspicuous both to the outward view and manifest from the operations themselves. From this there arose the separatory art and the method for arranging, separating, and modifying the harder bodies themselves, which came forth successively. Thesis 11. The sea itself supplies salt, so to speak universal and common, which is dried along the shores. It seems to have furnished the first knowledge of salt and to have communicated its use to all of the same operation. That its powers were known from very ancient times is confirmed both by general testimony and by sacred scripture, as regards the excellence of its actions in preserving and in vegetating bodies, whence they did not blush to call it the seasoning of nature, for things that are salted are preserved the more. Its efficacy with respect to vegetation is shown by lands that, when suitably salted, prove more fertile, marine fertility, whence the ancients said that Venus was born from the sea, as if the power of generating and bringing forth in all bodies were to be drawn chiefly from it. Accordingly they called bodies dead when they were deprived of salt, for it is by salt that bodies persist in motion and are mechanically knit together in a fitting texture. Take it away and you establish death, the flight of the spirit, and the rest that succeeds. From the defect or change of this saline matter there straightway arise things convenient or inconvenient, since it is the single instrument to which the body is most greatly subject in what is corporeal and sensible and in what is violently moved, helped by ether, fire, and air, and this is absolutely necessary both in our engines and in others. Its use confirms the same. Even the salacity, lustfulness, appears visibly around the parts destined for generation, hence they are called salacious, in which the seminal vessels swell, and the lustful are prone to venery. Hence it is no wonder that in cold diseases the effects about these parts are prostrations equal to those that occur about appetite and desire. Finally, because of all these considerations common salt has been a more familiar thing to humankind, both in foods for better digestion and for preserving from corruption. From all this it is no marvel that in divine worship the body should be touched with salt together with fire, since salt contains something naturally sacred, and in sacred rites the use of salt is most noble as a type of a more perfect, incorrupt, life. What this contributes in chemistry is not foreign to our subject. It is enough to say that these things give the greatest handle toward perfection, and provide the chief occasion for preparations and for obtaining medical remedies. In analysis too, the more inquisitive artist is wont to esteem possession of this, i.e., a knowledge of salts, most exact. The ancient theses sufficiently demonstrate this. For they open treasuries and unlock doors for inspecting actions and passions, and for bringing every accident forth from the darkness of bodies into the light. Thesis 12. We must warn, however, that salts are always to be regarded as active bodies, while the rest are passive, and that from common salt almost everything can be made, by the access and recess of certain bodies that differ from it in mass, shape, and motion. Men, being very much subject to their senses, advance step by step from what was most obvious to what was more rare and little known, at least to those things that presented to them the most perfect knowledge. And so they called these salts, potential fires, since they saw that motion and sensation increased from the least beginnings from the smallest occasion given. They insisted all the more on this because from volcanic mountains fires are thrust on high, and there are vomited forth salts, now aluminous, now vitriolic, now sulphureous, according as acid sulphureous flames are wont to strike and dissolve various matters. Even sal ammoniac, produced by fire, is brought forth from subterranean flames. Many places where it has been found bear witness to this, and there is no doubt it can be found elsewhere too. Therefore the sulphureous flames most conspicuous in volcanoes could have taught the ancients that not only by the irradiation of the sun are these hollows warmed, but that within there is a fire proper to the various regions, destined for motion, since the sun cannot penetrate into hidden places through the very dense structure of the world, nor can they be reached with the aid of cold and darkness which are perpetually creeping. From this fiery matter some, according to their opinion, have preferred to assert a certain star in the very middle of the globe. We leave this to those whose hearts are set more on contemplation than on action. Yet at least flame and the knowledge of it existed from the beginning, and, so the sacred writings teach, there was subterranean fire, therefore we must take this fire to be necessary, not something that entered by chance. Thesis 13. The effects of subterranean fire, besides the production of salts, were further shown to the ancients, whence they learned, nature pointing out the way, the passage of fluid and mobile things into solid and fixed. For oils come forth from bitumen in various ways, as naphtha, petroleum, earth oil, and countless other liquid sulphureous matters. Boilings and vapors are often raised. That these are copious in the more unhealthy waters is shown. Clouds and winds, from vents and subterranean crypts, issuing forth, are so common that they cannot be denied. Drippings and distillations of rainwater in hidden caverns of the seas occur without cease, and our doubt is forestalled. The effects of cold and of heat are common observations. In these vapors lifted on high our body is affected just as much as by the air, and the diverse regions of the very sky and of the earth. The deleterious and restorative works that proceed from these things, and from all that is near to animals and vegetables, are plain from the histories of places and, often, from the metaphors of poets. Earthquakes, arising from winds confined in narrow places, with an explosion and violent path prepared beforehand, are operations of these heats upon waters, causing greater action and rarefaction, and they often show themselves in a dreadful manner. These, then, are the chief things that occur with more fluid bodies, yet they can also have a place among the heaviest and most solid. For where the vapors are thicker, almost like a very heavy liquor, are caught up aloft, and here and there insinuate themselves along the sides, fissures, or surfaces of the partitions between the layers, they gradually condense and are converted either into a metallic or a mineral substance. Thus, being lifted nearer the earth's surface, they afterwards serve for human convenience and use. Thesis 14. Since these are the chief points that occur about more fluid bodies, it can also happen that in the heaviest and most solid bodies they have a place, for where the vapors are thicker, almost like a very heavy liquor, are lifted up, and here and there insinuate themselves along the sides, cracks, or surfaces of the partitions lying between the layers, they condense and are changed either into a metallic or a mineral substance. Thus, being raised to a higher level, they afterwards serve for human convenience and use. From the foregoing the way is clear and distinct enough for the curious investigators of nature to perceive the ascents of the more fluid saline, sulphureous part out of bodies and, as it were, their withdrawal from quiet and solidity. Hence come empyreumatic diets and evil sulfurs, or flowers of 5 kinds which the dryness lifted on high by fire and instruments compels, according as these appear in adherent places and the warmer regions, in caverns, and at springs where foundations are. Indeed they could naturally discern the differences of these oils, as well in nature as in chemistry, of which, even within the same kind, some are now white, now yellow, now blackish, and tinged with nigrescence, because bodies torn away in greater grossness rejoice in that greater crassitude. The same they perceive in different juices, in the fatty natural liquid before mentioned, as the inward stain sufficiently marks there the hidden exaltation and volatilization born within them, in these subterranean furnaces most pure and most defecated, which very often melt the metals, they have been shown where not only the salts of the inward parts and fixed signs of volatility appear. From this, without much improbability, it may be pronounced that chemistry won its greatest progress with the metallurgists, since in those places the most evident operations are conspicuous. From these imitations there were devised solid instruments for themselves, to imitate the subterranean crypts and the motions of fires confined and limited within straighter bounds. And thus the sacred letters, assigning the first true inventions of subterranean mineral works to Tubal-Cain and, among the pagans, to Vulcan, sufficiently bear witness. Thesis 15. From these premises it is easy to see that chemistry arose from the works of nature, inspected by the senses. These works were at first noticed here and there and, as it were, gathered by chance, and at length were reduced into the form of an art by the most diligent nations. And since there were nations that first cultivated this art, which is now quite certain, it seems believable that among the earliest peoples, not long after the creation and the fall of the world, this was cultivated not for ornament nor for the bare contemplation of things, but for the use and benefit of humankind, as was indicated above. Hence, as if it were a certain craft proper to some people or to a family, the craftsmen practiced this art, and at length, making gain and commerce out of it, they carefully noted down everything which could contribute to profit. From this it came about that luciferous, light-bringing, experiments were especially dear to them, and before the calculus of gain had yet flown to the skies, such experiments were sought here no less than in other sciences and arts. Nor does it hinder that the production of light should spring from a lust for light, for these can concur together in many cases, and thus both intentions and the extension of the art sprang up side by side. Accordingly the inquiries of individuals were scattered and dispersed, until, when experiences, cooperations, and observations had been brought together and compared with one another, they grew into a single, as it were, volume. But this could not happen except after long intervals of time, which yielded a riper fruit of science and art. Thesis 16. The first rudiments of the art seem to have flowed together among those who lived in settled communities and were guardians of secrets. A higher doctrine is greedily sought, especially where the civil commonwealth is more ordered and tranquil, a condition not found among barbarous and savage peoples. For the operations and experiences that sprang thence were carefully examined by them, and at length reduced into tables, then taken up anew and repeated, so that knowledge might be transferred from one to another. Thus, by faithful and unfaithful outcomes alike, they obtained observations and selections, winning light out of darkness. Thesis 17. After the flood the Egyptians' royal commonwealth, most well-known and most renowned, with their neighboring nations, the Phoenicians and Edomites, seems to claim the first place for itself in this art. Authors add that they so highly esteemed this knowledge that they laid it up among sacred mysteries, granting access to none except kings, the sons of kings, and the chief priests. Whether alchemy alone was the object of their intention is doubtful. It plainly seems not agreeable to reason, and far less is it credible that this nation, so circumspect in promoting medicine, should have neglected chymiatry. For writers state that more prudent remedies were collected from that nation, remedies useful then and now for this or that disease, and that they had physicians, learned men, and, in that department at least, all the more excellent. Whatever the case may be, I do not press authority here. Yet from sacred scripture it is clear that Moses, trained in Egyptian wisdom, was not ignorant of chemistry, as is shown in the burning of the golden calf, unless one prefers to call this a miracle, and in the prescription of the royal holy oil/ointment, where he joins an artful pharmacopoeia, undoubtedly a chemical preparation, so that it may agree with the requisites of a subtle essential oil, like dew descending and ascending, most pleasant in its fragrance and refreshing not only those who are anointed, but even all who stand nearby, by its lively character. That the Hebrews possessed chemical knowledge is further indicated, besides various admonitions about waters and salts, especially those that aid chemistry, by the most noble purifications of metals set before us by the prophets, when they speak of gold, silver, tin, and other metals cast into the furnace, thrown into the fire, the bellows blowing, and at last the dross being driven off in various ways with the smoke, though not without trouble. Finally, the tests that are offered for comparison concerning the improvement, alteration, and corruption of bodies are sufficient. To rehearse them all here would be too long. It is enough for my present purpose to have shown below that the chemical art is exceedingly ancient, indeed among the first of the world's sciences, beginning with Tubal-Cain and, without doubt, passing also to the Tyrians, for what else is that most noble purple of theirs, applied to wool, linen, and garments, than a chemical work? In Tyre, as historians relate, that kind of fish, the murex or shellfish, once abounded, from which, when crushed, the celebrated purple juice was expressed, now utterly extinct, so that no one any longer obtains it. If, then, there had been some other occasion for fishing these animals from the sea, why is it that before the Tyrians attained so great a mastery in this science no other nation made use of it? Before their maritime empire, unless leave were granted, no one could command the sea, yet to catch and transplant these creatures to other places, or even to lands, would have been presumed possible by others, if that little animal had not been lacking there. Why, finally, did Alexander the Great, when he captured mighty Tyre, seize those very precious shells for himself, not reserving them for Tyre's magnificence and transferring them thence, but rather finding that the oysters had retained their purple by their own nature, so that the neighbors did not know how to keep safe that most precious crimson? Perhaps someone will say that this liquor is diluted in the vessels of living animals and therefore was not communicated to the sea so long as the delicate vessels in living creatures remained sound and tight, preventing any outflow. But if no lurking death had overtaken those oysters, and if the fishes that fed upon them had kept the dye to themselves, this would certainly have needed to be shown. Indeed, even on rational grounds it is hard to believe that the purple tincture, once the animal was corrupted, could have been kept and preserved. If, therefore, a universal slaughter destroyed this kind of animal, the sea itself ought to have been made bloody, as we often see in corpses seized by a malignant disease and death, when hemorrhages and effusions of blood appear. In the end art was required, as we observe even today in the dyer's craft, which must draw its origin from chemistry, just as with cochineal and all other colored materials the art has been received from those nations that cultivate it. For since a Tyrian-like purple can be prepared without those shellfish, from gold, tin, and other materials, and since the prepared matter can afterwards be kept most excellently and securely on shells and on glasses without alteration, as many curious finds still show today, we conclude that Tyrian purple was a chemical invention, artificial and not natural. I do not yet speak of chemical waters, nor of other nations, nor of the most difficult parts of alchemy, nor of the other species of chemistry. I conclude only this, that this art, most renowned and most highly cultivated, has been fostered from the cradle of the world to this very day among whole nations and among true investigators of the works of nature, women and men curious in this theater who pursue not mere contemplation but labor, workmanship, and the service they set before themselves, equally in nature as in art. Further proof of this will be shown both in our own apparatus and in other instruments, namely, that the operations and exercises of the changes and vicissitudes of bodies tend toward most excellent and fruitful ends. The end. Corollaries. 1. Just as the outward appearance of bodies differs, so too does the structure of their internal parts, therefore nothing certain can be obtained in medicine from any general hypothesis about the shapes of vessels laid down at pleasure. 2. Inquiry into solid figures is very necessary for geography, but to draw conclusions from them for fluids, with mere presupposition, is very defective and useless in practice. 3. The propulsion of fluids through their own vessels is not altered unless something be added that mixes with the most intimate parts of the fluids themselves. 4. This intermixture must act upon the solid parts by imbuing them with the fluid, so that there follows a greater or lesser concussion of the partition walls or surfaces. 5. The alteration of fluid and solid depends on a twofold cause, 1, on irregularity or grossness, and, 2, on a certain separation of parts mixed with the subtler fluid from the vessels, when the channels, not admitting those crossed or altered parts, exclude them from their cavities or little tubes. 6. Hence any remedy, whether galenic or chemical, must be fitted to this operation, namely, that it affect the humors, both the solid and the fluid. 7. Salts, both in their spiritual substance and as enclosed in their own bodies, cannot always be limited by their generic name. 8. More distinctly considered, these things, treated everywhere by physicians and chemists and made properly their own, present themselves to the senses. 9. Accordingly, the question whether this or that salt is present and pre-existent in bodies is partly frivolous, partly conjectural, if we are speaking of the genus itself or of a distinct species of salts. 10. That the corruption of one is the generation of another holds only with respect to the forms and figures of salts and earths, not with respect to other things. 11. Blood, as blood, never contains within itself the primary cause of diseases. 12. We hold that chyle receives from blood nothing except a tincture. 13. We consider the menstrual flow not as an excrement, but as a mere extravasation. The end.